Good morning, students. Today is 26th February 2021 and we'll be taking the second topic of the first unit, first chapter. The topic is operations on sets. We have already seen what are sets. Now, well, let's begin with the operations on set. An operation on a set is where two sets are combined to produce a third result. So what we are going to do, we are going to perform some operation on the set, which is the collection of similar type of data. And on that data, we are going to perform operations like getting the data from both the sets, getting the only that data which is common to both. Okay. Likewise, we are going to perform some operations like in mathematics, you have addition of numbers, multiplication of two numbers, division of two numbers. These are the operations on the data or the number, that is called as arithmetic operations, and the operators which we use for it are plus, minus, multiply, divide. Similarly, we have operations to be performed on the set. Okay, so let's begin with the first operation, that is the union operation. The union operation is A union B such that A union B is equal to X, such that X exist in A or X exist in B. This topic is already covered in the previous class. Still, I am repeating first union and intersection. But let's begin with the union again. So A union B is equal to X such that X exist in A or X exist in B. I'll call it as E exist. Okay, or is in A. X is in A or X is in B. This is which operator we are using, or, that is union. So the element should, or the member should belong to the first set, or the member should belong to the second set, or the member should belong to both the sets. In case if it is so, then we call that X element should belong to the A union B. Let's say, for example, A, B, C, E, F are the elements of set A. B set comprises of B, D, R, S. Now, A union B will be consist of all those elements of A and B, all the elements of A and all the elements of B. And if there are some common elements, that should be written only once. So all elements of A should be there in A union B. All elements of B should be included in A union B. But in case if any element which is common should be written once, like B is common in both. So B is written only once. Then you have A, B, C, E, F. A, B, C, E, F. Okay. Then here B is there. D, then R, and then S. Since B is the only element which is common in both, so it is written only once. So how many elements are there in A set? 1, 2, 3, 4, 5. How many in this? 4, 1, 2, 3, 4. 5 and 4, total 9, out of which B is common. So here it consists of total number of elements as 8. 1, 2, 3, 4, 5, 6, 7, 8. And the Venn diagram for this is depicted like this. That is, set A comprises of all these elements A, B, C, E, F. Set B comprises of all the elements B, D, R, S. So when we combine these two sets, we have A union B as A, B, C, D, E, F, R, and S. If I depict all the elements in the Venn diagram, it looks like this. It is here you have A, B, which is common in both. So I'll write B in the common part. Then we have C, then we have E, then we have F. So all these elements are in A set. B set comprises of B, then we have D, then R, and the last element is S. So this is our Venn diagram, which consists of the elements of A and B also. The next operation is the intersection operation. The intersection operation means A intersection B. This is the operator which we use for intersection, is equal to X such that X exists in A and X exists in B. So here the element X should belongs to A. X should there X is in A and X is in B. So X should be there in B as well as in A. A and B दोनों में होना चाहिए. This is AND operation, intersection operation. Say for example, their set A comprises of A, B, C, E, F. Okay, set B comprises of B, E, F, R, S. So now what is common in both? It is B is common. So let's mark B as common, which is the intersection of A and B, then let's say C is not there, F is common, that's all. So there are E also is common. 3 elements in common between A and B. A is not there, B is common, then C is not there, E is common, then F is common. R and S are also not common. So we have marked the common elements. So now what is A intersection B? A intersection B is the common elements, that is A, B and F. Similarly, let's see the common elements in A and C. The common elements between A and C is, here we have A element, here we have A element. So let's find out the intersection of A and C. Then T is not common, U is also not common, and V is not common. So when we find A intersection C, so here we have only one element, that is A common in both. Similarly, let's see B intersection C. In B intersection C also we have A, B intersection C, A not common, B not common, E not common, F is not common, R is not common, S is not common. Similarly, T is not there in B set, U is also not in B set, and V is also not in B set. So here B intersection C is empty. It is empty. It is blank. No element is common between B and C. So B intersection C is empty. So the Venn diagram is depicted like this. This is the Venn diagram for A intersection B. Okay, let's see A intersection B, and then let's draw the Venn diagram for A intersection C. This is A and this is C. So now what is common in A intersection C? This is set A, which is denoted by capital letter, set B, which is denoted by capital letter B, and what is common in both intersection part, that is small a. So small a exists in capital A, small a is in B also, and small a is in A also. So this part is common, that is intersection part. Similarly, B intersection C. This is my B, this is my C. Okay, this is the intersection part. Now, is this diagram correct when I say B intersection C is empty? Is this diagram correct when I say B intersection C is empty? So do you find any element common in both? Is this diagram correct when I say B intersection C is empty? Tell me quickly. Or this diagram is correct. B and C are disjoint sets. Why I call B and C are disjoint sets? Because there is nothing common in both. It is empty. B के members और A के C के members बिल्कुल अलग है, distinct है. There is nothing common in both the sets. So both are written like this: B, C. So these two are distinct sets. These are called as disjoint sets. ये disjoint set है. There is nothing common in both. So this is the Venn diagram for intersection. Now let's see disjoint sets. Right now I told you about disjoint sets. Disjoint sets are the sets where the intersection results in the empty set. Here this is the common element which is there, and there is no common element. This is the disjoint set. So disjoint set is the set in which two sets are having nothing common between those two, and there is no intersection like this. So this is the diagram for the intersection, and this is the diagram for the disjoint. There is no disjoint over here, there is a disjoint over here. Two distinct A and B sets are there. Union and intersection across multiple sets. What do you mean by unions and intersections across multiple sets? Let's see. Both intersection and union can be performed on multiple sets. Say for example, you have A, B, C. So here what we are doing, we are performing the union operation on the three sets A, B and C. तीनों को मिलाकर यूनियन किया मैंने. A, B, C को तीनों को मिलाकर यूनियन किया. Now X, A union B union C is equal to X. That is, union of all three consists of the elements of X such that X is in A or X is in B or X is in C. तीनों में से किसी एक में भी अगर होगा तो that should be the part of the union. मतलब एक कोई भी एलिमेंट A का होगा या फिर B का होगा या फिर C का होगा, तो that element should belong to the union of A union B union C. Similarly, if I say the intersection of the three elements A, B and C, so X such that X belongs to, X is in A and X is in B and X is in C, मतलब तीनों में होना चाहिए वो. And this is the AND operation in intersection. It is an AND operation. Intersection means AND. It is common in all the three. A में भी होना चाहिए, B में भी होना चाहिए, C में भी होना चाहिए. If it is present in all the three, then we call it as an intersection. Now let's see A, B, and C. A union B is 1, okay, then 2, then 3, then 4, 5, 6 is not there, okay, 7, then 8, and then 9. The one which are repeated should be written once in case of common. So A union B is this. Now let's see C also. 1 is also there, 3 is there, 6 is there. So 6 is being included because of this. 7 is included here. 8 is included because of this. 9 is included here because of this. So 1, 1, 1 is common in all the three because we are taking A union B union C. So it is written only once. 2, 2, then 3, 3 only once, then 4, then 4, 4 is written once, 5, then 6 is here, 6 is written here, 7, 7 is written, 8 and 9, 8 and 9. So all the elements are written only once in case of union. Now let's see what are the common things in A union B union C. A is having 1, B is having 1, C is having 1. A is having 3, B is having 3, and C is having 3. Now, apart from this, nothing is common. So, A union B union C. A intersection B intersection C, that is intersection, that is common in all the three, is A 1, 3. Now, let's make the diagram for A union B union C. So, ये A है मेरा, ये B है, and this is my C. Okay. Now, what is A union B union C? This part, and this part. This common part should be written only once. This is the diagram for A union B union C. Now let's make the diagram for the intersection of A union B union C. Now what is common in all? This part. This part is common in all. That is intersection A intersection B intersection C. So this intersection comprises of 1, 3. Okay. So this is intersection. This is the Venn diagram for A intersection B intersection C. Now let's see complement. Complement, the complement of A with respect to the universal set U, all elements of the universal set U that are not a member of A. See, first of all, when we see what do you mean by complement. So before we begin with the complement, we should know what do you mean by the universal set. Universal set is the set which consists of all the elements belonging to that set which we are concerning. So that is our universal set. So universal set is always a bigger set. Okay. This is being denoted by the rectangle in the Venn diagram. Now this universal set consists of lots of elements. Let's say, for example, all set of numbers, all set of positive integers, like this. Okay. Now this is with respect to the set A which is given to us. So this is my set A which is given to us. Okay. So this part which is apart from set A, the set which is comprises of apart from the set which is comprises of universal set minus A set is called as complement of A, and this is called as A dash, that is complement. You denote it by this A dash, you denote it by A bar. Okay, these are the different ways in which you can write it. See here, A bar is written. A bar hai. A bar. Okay. So the complement of set A with respect to the universal set U minus all the elements of the universal set U that are not a member of A. जो A के member नहीं है उसमें वो वाले सारे elements A complement में आएंगे. मतलब universal set में से A set निकाल दिया तो ये जो बचा हुआ gray portion है, this portion, gray portion is the complement of A. It is being denoted by A bar. A bar भी denote करते हैं या A dash भी लिखते हैं. So for example, A is equal to X such that X is an integer and X is less than equal to 4. A is a set which consists of an integer values and is less than X is less than equal to 4. X जो है 4 से कम होना चाहिए. and U is equal to capital Z. Capital Z means set of all integers. So capital A bar, that is complement of A, is X such that X is an integer and X is greater than 4. Why I have taken X greater than 4? Because my universal set is comprises of Z. What is Z? Z is a set of all integers. So Z is a set of all integers. So U is equal to set of all integers. Say for example, if I write like this, minus terms dash 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 minus 2 minus 1 0 1 2 dash 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 dash. So it is open ended from both the side. So minus के numbers भी है, plus के numbers भी है. That is my universal set. And my A set is consist of all the elements which are integers and is less than equal to x is less than equal to 4. x जो है वो 4 से छोटा है. तो कुछ elements -2 -1 0 1 0 1 2 3 4. ये कौन से एलिमेंट्स होंगे? These are the elements of set A. Now what are this minus this? Universal set minus, I'll just write all these statements in Word. Universal set U consists of all the elements which are negative integers. Integer means which consist of negative values. Okay, and set A consists of set of all integers which is greater than equal to less than equal to x is less than equal to 4. X is less than equal to 4. So we have all negative values -2 -1 0 1 2 3 4. Now what is A complement B? A complement, what is A complement? That is A bar, A dash या फिर A bar भी लिखते हैं. It is equal to universal set minus A. This is equal to, then A में से ये माइनस करना है, यूनिवर्सल सेट में से A माइनस करना है. तो 4 के बाद जितने टर्म्स है 5 6 7 8 dash 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 0. So how do I write this? We'll write as A dash is equal to X such that X is a set of is a integer and X is greater than 4. X greater than 4 is always 5 6 7 8 9 10. So X dash is my complement. Okay. Okay, so X complement is equal to X such that X is an integer and X is greater than 4. Why equal to is not included? Because equal to is in set A, and here we are finding out complement of A. So complement of A is A U minus A. U में से A माइनस करना है. U क्या है? U set of all integers है. All integers में से A माइनस करना है. A मतलब लेस देन इक्वल टू 4. जब A लेस देन इक्वल टू 4 माइनस किया तो क्या बचा हुआ? X is greater than 4. Now complement with respect to the other element. The complement of B with respect to A, that is all elements belonging to A but not to B. So here we have to find out complement with respect to, not with respect to universal set, but we have to find out the complement with respect to some other set. अगर कुछ नहीं है तो यूनिवर्सल सेट के साथ में कॉम्प्लीमेंट निकालते हैं, और अगर कुछ दिया हुआ है तो उस सेट के साथ में कॉम्प्लीमेंट निकालते हैं, दैट इज माइनस. सो लेट्स say that if u is the universal set, is the complement and is replaced by a, so let's say it is denoted by a minus b. so a minus b, that is b जो है वो माइनस हो रहा है a में से, तो a हमारा पूरा बड़ा सेट हो गया, a में से b को माइनस करना है. so that is x such that x is in a and x is in b. so x is in a as well as x is in b. it is being denoted like this. now how do you write it like this? assume a is equal to a b c and b is equal to b c d e. okay, now a में से a b c में से b के जो एलिमेंट्स कॉमन है उनको माइनस करके जो बचे हैं वो एलिमेंट्स को लिखना है. a में स्मॉल a है, इसको लिखा. b जो है दैट इज कॉमन इन बोथ, सो विल remove the b part. b is common in both. then c is common in both, it is being removed. so it is a is my full set. उसमें से b के जो भी एलिमेंट है इसके अंदर उसको माइनस करना है. a के अंदर क्या है? a b c. ओके, एंड ए बी सी में कौन से एलिमेंट्स b के जो कॉमन है वो निकाल देना है. b के अंदर स्मॉल b है, इसको निकाल देना है. b के अंदर स्मॉल c है, उसको निकाल देना. will be left only with the element a. so a minus b is equal to a. that is x such that x exists in a, x such that x exists in a, and x exists in b, and x exists in b, but that x which exists in b, which is common in both a and b, should be removed. Suppose if I say this statement is not correct, I have to correct this statement. This is wrong. Let's see the statement again. b minus a, this b is equal to small b c d e and a is equal to a b c. अब माइनस करना है, देखो b c d e, ये हमारा b का सेट हो गया. अब इसमें जो a के एलिमेंट्स है उसको निकाल देना है. a में क्या है? स्मॉल a है. इसमें है क्या? नहीं. b के अंदर स्मॉल b है, a के अंदर स्मॉल b है, इसको निकाल देना है. a के अंदर स्मॉल c है, इसको निकाल देना है. सो विल बी लेफ्ट ओनली विद d and e. so we'll left only with d and e. okay, so here this is b minus a, b, this is my b. okay, this is my a. okay, इस पूरे b में से a के जो एलिमेंट्स थे उसको निकाल दिया है, तो बचे कौन से? ये वाले एलिमेंट्स. इस पूरे b में से a के जो एलिमेंट्स थे उसको पूरे निकाल दिया, तो व्हाट इज लेफ्ट? वी आर लेफ्ट विद दिस, दैट इज d comma e. this is b minus a. similarly in this case a जो एलिमेंट दिया हुआ है, इस a एलिमेंट में से b के जो एलिमेंट्स है उसको हमको रिमूव करना है. okay, so here this is my a set. a set consists of a b c, a b c. now what is common in both is b and c, so we left with only a element. so a is a minus b. this a is this a element is a minus b, so only one element which is left is a. This sentence is not correct, I have to check this sentence. okay, I'll let you know this sentence later on. so this is with respect to b, we have taken complement. okay, now let's say symmetric difference. Symmetric difference is if a and b symmetric difference, if a and b are two sets, the symmetric difference is the set of elements belonging to a or b but not both in a and b. इट बिलोंग्स टू ए और बी बट नॉट बोथ टू बोथ कॉमन. कॉमन पार्ट निकाल देना है. ए को भी बिलोंग करना चाहिए, बी को भी बिलोंग करना चाहिए, पर जो दोनों में कॉमन है उसको निकाल देना है. इट इज डिनोटेड बाय दिस symbol. This is XOR symbol basically. A XOR B symmetric difference is equal to X such that X is in A and X is not in B, or X is in B and X is not in A. That is common part should not be there. X is in A and X is not in B. X is in A but X is not in B. ये वाला part. Similarly, X is in B, X is in B, but X is not in A. A में नहीं होना चाहिए, A का पार्ट नहीं होना चाहिए, B का सारा वो पार्ट जो A का पार्ट नहीं है, A का वो सारा पार्ट जो B का पार्ट नहीं है, that is common part should be removed. So this can be written as A minus B union B minus A. So this is the symmetric difference. So for this, suppose if we have a set A, we'll find out A. I'll just take one example. If we have, suppose, set A is equal to A comma B comma C comma D comma E comma F. Okay, and we have set B is equal to B comma C comma F comma G comma H. Okay, so we have A symmetric difference, that is plus, and I'll just write symmetric difference B. It is equal to A minus B union B minus A. Okay. Now what is A minus B? A minus B is equal to A minus B. All the elements of A which are not in B. Okay. All elements of A I have written. From this we have to subtract the elements which are in B. तो B में क्या है? ये B, इसको निकाल देना है. Okay. फिर then C है, C भी इसमें है, इसको भी निकाल देना है. Then F है इसमें, इसको भी निकाल देना है. Then G नहीं है, H नहीं है. So A minus B is this. Similarly B minus A. So I'll write B first. B is B comma C comma F comma G comma H. Okay. Now from this set B minus A जो common है वो निकाल देना है. A इसमें A है, यहाँ पर A नहीं है, निकाल नहीं सकते. B है, B निकाल देना है. C इसमें है, C इसमें से निकाल देना है. Then D इसमें है, इसमें नहीं है. E नहीं है, F कॉमन है, निकाल देना. Now we'll find out A minus B union B minus A is equal to A comma B comma E comma G comma H. That is, let's see, इन दोनों में जो कॉमन एलिमेंट्स है वो निकाल दिए. A कॉमन नहीं है, ये लिखा. B कॉमन है, निकाल दिया. सॉरी, B नहीं आया. A comma union क्या ना, A D E G H. So A is not common, A we have written. B is common, we have removed. C is common, we have removed. D is not common, so D is written over here. Then E is not common, E is written over here. Then F is common, we have removed. Then G and H are not common, G and H are written over here. So this is A union B, A minus B union B minus A. That is symmetric difference. This is called as symmetric difference, which is denoted by this. Which is denoted by this symbol, plus encircle. Plus is encircle. ये प्लस से encircle किया हुआ है, ये XOR का सिंबल भी बोलते हैं. Now let's see some of the properties. Some of the properties of set operations are commutative property. A union B is equal to B union A. A intersection B is equal to B intersection A. Associative property A union B union C. You associate B and C first, then you can associate A or B also first. There is no difference. Then A intersection B intersection C, A B फर्स्ट इंटरसेक्शन फाइंड आउट करना और बाद में इसका, या B और C का पहले फाइंड आउट करना उसके बाद में A के साथ में. तो दिस इज एसोसिएटिव. दीज आर द प्रॉपर्टीज व्हिच आर ऑलरेडी प्रूव्ड प्रॉपर्टीज. Distributive property A intersection B union C. A is being distributed among B and C. तो A intersection B union C. तो A को हमने B के साथ में दे दिया, यूनियन A को हमने C के साथ में दे दिया. Similarly A union B intersection A union C. Okay. Next property is idempotent property. A union A is equal to A. A intersection A is equal to A. This is idempotent property. You might have learned these properties in your undergraduation discrete mathematics subject. Now the properties of the complement. A double complement is equal to single A. A union A complement is equal to A union A complement. A और A का complement पूरा union form करेगा. A intersection A complement is nothing, that is phi. Phi का complement पूरा universal set का complement phi. De Morgan's law. A union B whole complement is equal to A complement. Union is converted to intersection B complement. Similarly, A intersection B whole complement is equal to A complement or B complement. Okay. Properties of universal set. A union union is equal to union. मतलब यूनियन के साथ में किसी को भी सेट को यूनियन करेंगे तो यूनियन ही आएगा, और कोई भी सेट के साथ में यूनियन को इंटरसेक्शन करेंगे तो वही सेट आएगा. Similarly, properties of empty set. A union empty set is always A. This can be written like this also. A intersection empty set is equal to empty set. A intersection phi is equal to this. इस तरीके से लिखो या इस तरीके से लिखो, this way or this way. Okay. Now addition principle. The addition principle associates the cardinality of the sets with the cardinality of their union. So if A and B are the finite sets, then A union B absolute value is equal to A plus B minus A intersection B. Now this is the theorem which you have to remember, and let's see the Venn diagram for this. This is my first set. This is, say for example, this is the set which consists of 1 and 2 elements. This is the set which consists of some elements 1 and 2. So this part is my intersection part. So A absolute value of A plus absolute value of B minus A intersection B. एक बार जो दो बार है ना, ये दो बार रहता है. A और यूनियन B जब हमने किया तो A के पूरे एलिमेंट्स लिखे हमने, B के हमने पूरे एलिमेंट्स लिखे, तो A के जो कॉमन एलिमेंट्स है वो एक बार आ गए, B के जो कॉमन एलिमेंट्स है वो दोबारा आ गए. तो ये दो बार जो B के एलिमेंट्स आए हैं उसमें से एक बार जो B के एलिमेंट A B के कॉमन एलिमेंट्स है उसको रिमूव किया है माइनस A इंटरसेक्शन B. आर यू गेटिंग? A के सारे एलिमेंट्स, B के सारे एलिमेंट्स, पर A और B के कुछ एलिमेंट्स कॉमन होंगे तो वो कॉमन एलिमेंट सिर्फ एक ही बार लिखना है. तो एक बार जो ऑल पहले से है, दो बार हो गया ना, दो में से एक बार जो है उसको निकाल देना है. A के साथ में एक बार एलिमेंट्स, B के साथ में एक और बार एलिमेंट्स, तो दो में से एक बार में निकाल दिया, तो दैट इज माइनस A इंटरसेक्शन B. रोमन न्यूमरल्स इंडिकेट हाउ मेनी times each segment is included for the expression A plus B. Therefore, we need to remove A intersection B since it is counted twice. Okay, now I am closing the session.